We've all heard of the story of how an apple that dropped on Isaac Newton's head inspired him to develop the law of gravitation. With this discovery, he unveiled more secrets of the natural world. In 1687, he published Principia, which is considered one of the most significant works in science. Most knownly, one key point was that it described Newton's laws of motion. Newton's laws of motion is the foundation of physics. It's everywhere in life, from sitting down to playing your favorite sports, to how cars work and even lifting a spoon to eat cereal. For example, Newton's laws applies to running. Newton's first law of motion states that if an object is at rest, it stays at rest. When an object is at motion, it stays at motion. However, both will change if an unbalanced force acts upon it, also known as the inertia law. Inertia is the tendency to resist change in states of motion. If it wasn't for the muscles in your legs, you wouldn't be able to move. Your muscles exert a force into your feet, which exerts a force back onto the ground, propelling you forward. It's the same thing when you slow down. If I immediately stop, I would probably trip. When slowing down, our muscles actually tense up and apply a bigger force on the ground to stop.
Newton's second law of motion explains to us that force is directly proportional to mass and acceleration, but mass and acceleration is indirect proportional to each other. Simply, that famous equation is called m times a equals 4. Kathy is running with a 5-pound backpack on. Because she is holding more mass now, inertia has also increased, and it is more difficult to run up the hill. Her acceleration decreased while her force has increased.
For every action, there's an equal and opposite reaction. This means that if object A exerts a force on object B, then object B exerts a force on object A with equal magnitude, but in an opposite 180 degrees direction. Forces always work in pairs, call it an action and reaction forces. In the video, Kathy was exerting a downward and leftward force to the ground. At the same time, the ground exerted an equal and opposite force, which is upward and leftward force back to Kathy's feet.